Hello to the people. This is AP Calculus Lecture 2.2a called Basic Differentiation Rules, and in your book, open up to page 110. So we're getting out of today the definition of the derivative, which is such a tedious way to take a derivative. And I'm going to start showing you shortcuts to that. And I hope you don't get mad at me after doing those section 2.1 homeworks, and those problems were so tedious. But going through a couple of basic differentiation rules. And the first thing I wanted to talk about before we start working on these rules is some different ways to express the derivative. Now, we've looked at this way, f prime of x. Okay. Another way to express a derivative, saying is y prime. We'll use both of those a lot. They mean the exact same thing. Just this means the derivative of f of x. This means the derivative of y. It's the same thing. Another way is dy dx. We'll see that a lot, and we'll use that a lot in the future. That means the derivative of y with respect to x. That's how you say that. Derivative of y with respect to x. And also d over dx. That's actually a verb. That means take the derivative with respect to x. Okay, take the derivative with respect to x. All right, let's go with our first rule. It's called the constant rule. And that is the derivative of a constant is 0. Okay, let's do an example. Let's say we have f of x is equal to 7. Just a constant. So the derivative, f prime of x, is equal to 0. Now why is that? Well, a constant, f of x equals 7, is just a straight line at y equals 7. Well, the slope of a straight line, the slope of the tangent line at any x value is going to be 0. And that's all the derivative is. The derivative is the slope of a tangent line at a point, and at all the x points, the slope is equal to 0. So that's where the constant rule comes from. Okay, this is the rule you're going to use the rest of the year, the power rule. You're going to use the constant rule a lot also, but the power rule. This rule is embedded in all the other rules. So here's how it goes. If f of x is equal to x to the n power, f prime of x is equal to n times x to the n minus 1. So you bring the exponent out front and multiply times x, and then subtract 1 from the exponent. All right? So that's all we had to do on all of those problems that we were using the definition of the derivative. We could have literally done some of those problems in 5 seconds. So let's work some examples using the power rule from the book. So starting with example 4 on page 110, and I'm going to do 5 of these. So on number 4, it is f of x is equal to negative 2. So f prime of x, well, that's a constant, so it's equal to 0. Let's do example 6. We've got g of x is equal to 3x minus 1. So g prime of x, all right, we're going to use the power rule. The derivative of negative 1, so you can take the derivative of each one individually. The derivative of negative 1 is 0. So what's the derivative of 3x? Well, we could write 3x. I'm going to do it down here. 3x is equal to the same thing as 3x to the first power. Okay, that's the same thing. So that if it's the first power, we just don't write it. So using the power rule, we would bring the 1 out front. So it'd be 1 times 3 times x to the, all right, 1 minus 1. We subtract 1. So that's going to be 3x to the 0. Well, what is anything to the 0 power? It's 1. So that's just 3. So the derivative of g prime of x, you just drop the x when it's to the first power, and it's just going to be 3. And then the derivative of negative 1 is 0. So the answer is g prime of x equals 3. So you can take the derivative of, so the derivative of 7x is going to be 7. The derivative of 1/2 x is going to be 1/2. You just drop the x because it's going to end up, when you subtract 1 from that exponent, it's going to be the 0 power. All right. So let's do number 8. We have y is equal to t squared plus 2t minus 3. All right, xt doesn't matter. So y prime, since we're starting with y, we're going to say the derivative is y prime. Okay, the power rule for t squared. We're going to bring that 2 out front. So that's the same as 2t to the 2 minus 1. Okay, that's the power rule. Bring the exponent out front and then subtract. Now you'll be able to do this in your head after you practice it. Now we just said the derivative of 3x was 3, so the derivative of 2t would just be 2. And the derivative of negative 3 is 0. So that's going to be 2t to the first power. It's the first power. We don't have to write it. So it's just 2t plus 2. All right, let's see if we can fit 10 on here. So 10, y is equal to x cubed minus 9. So y prime, we're going to bring the 3 out front and subtract 1 from the exponent. So that would be 3x squared. What's the derivative of negative 9? It's 0. So 3 times x minus 1 from the exponent would be 2. So that answer is just 3x squared. All right, number 12. We'll go ahead and erase these. So 12, we have f of x is 2x cubed minus x squared plus 3x. Okay, this is a good one. So f prime of x, bring the 3 out front and multiply it by the 2. 3 times 2 is 6. Then there's x, and then subtract 1 from the exponent. That's 6x squared. All right, the middle term, bring the 2 out front, so minus 2x, and then subtract 1 from 2 is 1, so we don't have to write the 1, but that's what it is. so I'm going to erase that. And then the derivative of 3x would just be 3. It's officially 3x to the 0, but just be 3. And so at the point x equals 2, you'd plug in a 2 for x, and you'd get the slope of the tangent line to f of x at the point x equals 2. All right, great. Now I'm going to erase some of this to give us more room to work. All right, example 18. Okay, we have, and remember the power rule is f prime of x is equal to n times x to the n minus 1. Okay, so example 18, we have y is equal to 2 over 3x squared. Now, what we want to do is rewrite this, because the x squared is in the denominator, and we don't know the rule for that yet. So I'm going to rewrite this as 2/3 times x to the minus 2. Remember, we can bring that x squared up top if we make the exponent negative. These two are the exact same thing. Now we can use the power rule. So the derivative of this, again, this, and this, the exact same thing. I just rewrote it, 2/3 times x to the minus 2. In fact, if you want to write, some people write it like this, 2x to the minus 2 over 3. But I think it's a little easier to see if you write the fraction out front. Okay, if you want to do it this way, that's totally fine. But those are the same thing. Now, we're going to take the derivative, so y prime, negative 2 times 2/3 is negative 4/3. Times x, and then subtract 1 from negative 2, that'd be negative 3. Now this is the correct answer, but most mathematicians, most math teachers, including me, make you make the exponent positive. You might remember I made you do that in pre-cal and in algebra 2 as well. So that's going to be y prime is equal to negative 4 over 3x cubed. So we're just going to bring the x to the negative 3 downstairs and make the exponent positive, and that's the way that you need to express the answer. All right, let's look at example 22. That is y is equal to 4 over x cubed. Actually, x to the negative 3. Well, this one's really easy to rewrite. That's y is equal to, so we're going to rewrite that as 4x cubed. Bring that one upstairs. So what's the derivative of 4x cubed? You do that in your head before I do it. All right, we're going to multiply the 3 times the 4 out front. That's 12 times x, and then subtract 1 from 3, 12x squared. All right, hopefully you're getting the hang of it. We'll do a few more examples. Number 36. All right, we have h of x. This is a good one. Some students miss this at first. 2x squared minus 3x plus 1 over x. Now, we don't have a rule yet for a fraction that has x's in both the top and the bottom. We can deal with the fraction as a coefficient, but we don't have that rule. There is a rule for that. But it's much easier to rewrite since there's just a single denominator. you can rewrite this. I'm going to do it the long way, but I hope you can just do this in your head. This is the same as 2x squared over x minus 3x over x plus 1 over x. It's the exact same thing. That and that, exactly the same. You can divide x into each element of the numerator. Well, now we can simplify that further. What's 2x squared over x? Well, you cancel an x, cancel one of those, and it's just 2x. Here the x's cancel, so minus 3. And then how can we write 1 over x? That's an advantageous way to use the power rule. It's x to the minus 1. Remember, that's 1 over x to the first power. Bring the x upstairs, and it's x to the minus 1. Now we can use the power rule. What's the derivative of 2x? Well, remember, you just drop the x when it's to the first power, so it'd be 2. What's the derivative of negative 3? That's 0. And then we'll use the power rule on this. Bring the negative 1 out front, so that would be minus 1x, and then subtract 1 to the minus 2. So I need to clean that up. That's going to be 2 minus 1 over x squared. That's how I want you to write that. Make those negative exponents positive in the final step. So 2 minus 1 over x squared. All right, let's do one more example, and then we'll get into some simple trig derivatives. All right, 38. We have y is equal to the third root of x plus the fifth root of x. Well, we want to rewrite this without the radicals, with fractional exponents. So that's x to the 1/3 plus x to the 1/5. Okay, remember what's in the crook of the radical is the denominator. Okay, so this is x to the first power. What's in the numerator is what's the exponent under the radical. So if this were the cube root of x squared, what would that be? That's x to the 2/3. Okay, that goes on top. What's in the crook goes on the bottom. So since there's nothing written, it's a 1 is implied there. Okay, so now we can just use the power rule. It's with a fraction. So y prime is equal to, bring the 1/3 out front, and then it's x to the 1/3 minus 1 plus 1/5 times x to the 1/5 minus 1. Well, what's 1/3 minus 1? That's 1/3 minus 3/3, so that's negative 2/3. And then what's 1/5 minus 1? That's 1/5 minus 5/5. So I'm getting a common denominator with that 1, so that's negative 4/5. So y prime is going to be 1/3 x to the minus 2/3 plus 1/5 x to the minus 4/5. Now, are we done? Well, you'd get most of the credit if you got to that, but you've got to make that exponent positive as a final step. So that's the same thing as 1 over 3x to the 2/3 plus 1 over 5x to the 4/5. Okay, so we just brought the x to the negative 4/5 downstairs. There's a 5 out front. That 5 and 3 are both downstairs. And you don't have to turn it back into radical form for me. All right. So that's our examples for non-trig, I'm just going to give you a couple of elementary trig rules. We'll do a lot more trig later on. So you've got to memorize these rules. If f of x is equal to sine x, f prime of x is equal to cosine x. So the derivative of sine is cosine. And if f of x equals cosine x, f prime of x is equal to negative sine x. What that's saying is, for a sine wave, right, sine wave, if I want to get the slope of the tangent line at a point on the sine wave, let's say it's right here, whatever that point is, plug it in to cosine, and it will tell you the slope at that point. And same thing, cosine, let's say I wanted the cosine at 2. Then you take the negative sine of 2, and it would give you the slope of the tangent line at 2. Okay, let's do some examples with sine and cosine. So our first example is 14. Again, we're on page 110. And that is y is equal to 5 plus sine x. Well, the derivative of 5, we're just splitting each element. We're taking the derivative of each term alone. So derivative of 5 is 0. Derivative of sine is cosine. So y prime is just cosine x. Easy peasy. Number 16. We have y is equal to pi cosine t. So y prime, okay, the coefficient, we don't have to do anything with that. It doesn't have a t in it. So that it can't. If it did, it would be much more complicated, and we'll learn how to do that. But for right now, that's just going to be pi times, what's the derivative of cosine? Negative sine t. Well, you want to make it look pretty, bring that negative out front, and that's negative pi sine t. And our last example of this lesson is 42. So we have y is equal to 2 sine x plus 3 cosine x. So y prime is going to be 2 times the derivative of sine. Well, that's just 2 cosine x. And then 3 times the derivative of cosine. So 3 times negative sine x. That'd be minus 3 sine x. Again, that's going to be 3 times negative sine x, right? I'm going to bring the negative out front, and that'll make it a minus there. And that's all there is to it. Okay, the homework is page 110, 1 through 47 odd. All of those are in, the answers are in the back of the book, so you can check your answers, and I'll make a solutions video, and you'll only need to watch those that you couldn't get right. So 1 through 47 odd, all the answers in the back of the book. That does it for lecture 2.2a, and I will talk to you next video.